Hi, welcome to lesson 2.1. Now, before we start, the first thing that I need you guys to do is to tear out pages 33 to 64 on your journal. So once again, that's pages 33 to 64 on your journal, and this is for chapter 2. Okay, once you do that, then we are ready to begin our lesson. Now for this lesson, you're going to need a couple of highlighters because there's a lot of important terminology that you guys need to know. Okay, so let's start first with a conditional statement. Okay, now today's lesson is all about conditional statements. Now, a conditional statement is symbolized by P, then Q. Okay, can be written as an if-then statement in which P is the hypothesis and Q is the conclusion. Okay, so here's an example. If a polygon is a triangle, then the sum of its angles is 180 degrees. Okay, so you notice that this statement is an if-then form. Now, following the if, you have what we call the hypothesis. So a polygon is a triangle is considered to be our hypothesis. Our conclusion is the sum of the angle measures is 180 degrees. Okay. Let me change colors because orange is not working today. Okay, so the sum of the angles of its angle measures is 180 degrees. So if hypothesis, then conclusion. Okay, so once again, if a polygon is a triangle, then the sum of its angle measures is 180 degrees. And this happens to be a true statement. So let's move on to a couple more examples in the exploration. What we're going to do is we're going to determine the validity of these statements to see if they're true or false. So a hypothesis can either be true or false. The same is true of its conclusion. For a conditional statement to be considered true, the hypothesis and the conclusion do not necessarily both have to be true. So depending on what it says will depend on whether it's right or not. Okay, so here's our first example. If yesterday was Wednesday, then today is Thursday. Okay, so once again, if yesterday was Wednesday, then today is Thursday. So let's identify the hypothesis. The hypothesis in this case is if yesterday was Wednesday. The conclusion is then today is Thursday. So in this case, this is a true statement. B, if an angle is acute, then it has a measure of 30 degrees. So hypothesis, if an angle is acute, then it has a measure of 30 degrees. Okay, so if an angle is acute, then it has a measure of 30 degrees. And we know this is false because we know that other angles can have a different measurement that is not necessarily 30 degrees. Okay, so in this case, this is false. Okay, C. If a month has 30 days, then it is June. Okay, we know that is false because we do know that other months, also have 30 days. So this is false. D. If an even number is not divisible by 0, then 9 is a perfect square. Okay, so let's read this again. If an even number, that's 2, 4, 6, 8, 10, so on, is not divisible by 2, then 9 is a perfect square. So we know this part here is false. So this whole statement is false. Now, we based our validity based on our prior knowledge about days and angles. Now, what about if you have a diagram? Okay, we're on page 33, by the way. Okay, looking at this diagram, they're asking us to determine if this is true or false. Okay, the first one is triangle ABC is a right triangle. So first thing we need to identify is triangle ABC. So triangle ABC is this one right here. Now, because BC is a horizontal segment and AB is a vertical segment, we know that their intersection is going to be a right angle. And because this is a right angle, that would make this a right triangle. So we know that this is going to be a true statement based on the fact that if you form a triangle, it will be a right triangle. Okay, turn the page to 34. Okay. BDC is an equilateral triangle. So BDC is an equilateral triangle. Okay. As we can see, this is not going to be true because the distances are not going to be the same. The distance from here to here is not going to be the same as the distance from here to here. So in order for it to be an equilateral triangle, all sides have to be the same. So this is going to be false. BDC is an isosceles triangle. So BDC is an isosceles triangle. Now, in order for a triangle to be isosceles, you have to have at least two pairs of congruent sides. Now, this side right here, it's 4 by 5, which means that if I do Pythagorean theorem, it should be the same as this one because this is also a 4 by 5. So we know that BD and DC are going to be congruent. Okay? You could do the distance formula to verify if you would like. But in this case, this is indeed true. Okay, now for D, quadrilateral ABCD is a trapezoid. So look at the diagram and determine if it's a trapezoid or not. So A, B, C, D. Now a trapezoid is a quadrilateral that has only one pair of parallel sides. Now because BC and AD are horizontal segments, then that would mean that this quadrilateral, these two segments are going to be parallel, so therefore this is going to be a trapezoid. So this one is true. Quadrilateral ABCD is a parallelogram. We know that that is false because a trapezoid can never be a parallelogram because a trapezoid has to have one pair of sides parallel and one pair that are not parallel. And as you can see, AB and CD are definitely not parallel. So we're going to say that this is going to be false. All right, a little bit more of determining whether a statement is true or false. Okay. All right, A. If ADC is a right triangle, then the Pythagorean theorem is valid for ADC. We know that's true because the Pythagorean theorem works for only right triangles. B, if angle A and B are complementary, then the sum of their measures is 180 degrees. Okay, we know that that is false because complementary angles add up to 90 degrees. So that will be false. If figure ABCD is a quadrilateral, then the sum of its angle measure is 180 degrees. Now, the only polygon whose angle measure sum is 180 degrees is a triangle. And a triangle is not a type of quadrilateral. So this is going to be false. If points A, B, C are collinear, then they lie on the same line. That's true. We did say that if 3 points are collinear, then they're in the same line. All right, and the last one. If AB and BD intersect at a point, then they form two pairs of vertical angles, and that is true. If you have line A, B, and they intersect BD, say that is D, then you're going to get two pairs of vertical angles, and that's true. That's this one and this one, and this one and this one. Let me move the B out of the way so you can see it a little bit better. Okay, so imagine that point right there is B. So this angle is vertical with that angle, and this angle here is vertical with that angle right there. All right, don't worry about these two. All right, now let's move on to page 35. Now on page 35, I'm simply going to tell you where the problems are going to go. Okay, so page 35. Okay, on page 35, problem number 1 is going to go right next to the word conditional statement. Problem number 2 is going to go right next to conclusion. And problem 3 is going to go right where it says inverse. Now, number 3 has a lot of space because it's going to require us to do quite a bit of writing. So make sure you have plenty of space and that you organize yourself enough space for 4 parts to this question. All right, turn to page 36. All right, let's recap. Let me put that there. Okay, so a conditional statement is a logical statement that has 2 parts. A hypothesis, that we're going to use the letter P to denote the hypothesis, and a conclusion that we're going to call it Q. When a conditional statement is written in if-then form, the if part contains the hypothesis and the then part contains the conclusion. So in words, it's going to read if P, then Q. In a symbolic form, it's going to look like this. P, arrow, the arrow is facing the Q, so the hypothesis is going towards the conclusion. Okay, there's a word that says imply, so that little arrow means implies. Number 4 is going to go right there. Now, the next part is really simple. It's called a negation. The negation of a statement is the opposite of the original statement, whether it's the hypothesis or a conclusion. Okay. To write the negation of a statement P, you write the symbol for negation, and it's kind of hard to see, but it's like a little squiggly line right before the letter. So, and it's called not P. Okay, so the words not P in symbolic form, there's a little squiggle line. I'm not sure what this is called. P is kind of like a negative, you would say. And problem 5 is going to go right here. Now, what are you going to do with these conditional statements? Quite a bit of stuff. Okay, so there are 4 things that you need to learn how to do. Okay, well, 3 or 4. Okay, the first one is when you have a conditional statement. Okay, the conditional statement is written in if P, then Q form. This is like what we call the original. Okay, the very first thing that you're going to need to know how to do is the converse. Okay, converse. Now, to write the converse of a conditional statement, you exchange the hypothesis and the conclusion. In other words, you flip these two. Now, what you're going to have to do is you're going to have to work around the grammar in order for the sentence to make sense. Okay, so in our original conditional statement, if P, then Q. If hypothesis, then conclusion. In the converse, the conclusion becomes the hypothesis and the hypothesis becomes the conclusion. So you reverse them. If Q, then P. The next one is the inverse. Okay? To write the inverse of a conditional statement, you negate both the hypothesis and the conclusion. So if the original is if P, then Q, the inverse is if not P, then not Q. If not P, then not Q. Okay? So converse, inverse. Okay? And the next one is going to be on page 36. Okay? And it's called a contrapositive. So the contrapositive, to write the contrapositive of a conditional statement, first write the converse, then write the negation of the hypothesis and the conclusion. So if the original one is if P, then Q, then the contrapositive is going to be if not Q, then not P. Now, if any of these are going to be true, like the conditional statement, we call them equivalent statements. So a conditional statement and its contrapositive are either both true or both false. Similarly, the converse and the inverse of a conditional statement are either both true or false. In general, when two statements are both true or both false, we call them equivalent statements. Now, the last part is called a biconditional. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. A biconditional statement is a statement that contains the phrase if and only if. So there's not going to be any if then. Okay? So P, if and only if Q. Now the symbolic form for that is it's like an arrow going in both directions and stands for if and only if. Okay? Now we're going to go ahead and get started with our first example. Okay, here's example number 1. Now, I don't have a red pen, but I do have color highlighters. And that's what we're going to be using. It says use red to identify the hypothesis. Well, I'm not going to use red, I'm going to use purple. And I'm going to use blue to identify the conclusion. Okay, so what we're going to do is we are going to convert these into if-then statements. All right, so here you have all birds have feathers. Okay, so we need to come up with a hypothesis for this. And our hypothesis is if an animal is a bird. Okay, so our hypothesis is going to be all birds. And their conclusion is going to be that they have feathers. So my goal is to convert this into a working sentence in if-then form. So it's going to look something like this. Okay. If an animal is a bird, if an animal is a bird, comma, then it has feathers. You guys are literally getting the best handwriting I can. Work with me, guys. All right, so for B, you are in Texas if you are in Houston. So here they kind of give away the hypothesis. So in this case, the hypothesis is if you are in Houston. And the conclusion will be that you are in Texas. Okay? So, if you are in Houston, then you are in Texas. Okay, so we just converted both of these phrases into a conditional statement in if-then form. Okay? Now, that's number 1. Let's look at number 2. Okay, number 2 is really, really simple. It says write the negation of each statement. So the negation of the ball is red would be the ball is not red. Easy as that. Now remember guys, if I go too fast, pause the video and then replay it. B, the cat is not black. So the negation of the cat not being black is that the cat is black. Okay, so negations, really, really simple. Okay. Now, let's take a look at number 3 now. Number 3 is going to involve quite a bit of writing, guys. So bear with me. I'm trying to fit it in this shot here. Okay, it says, let P be you are a guitar player and let Q be you are a musician. Write each statement in words and then decide whether it's true or false. Okay, so what we're going to do is I'm going to worry about writing down the sentences first, and then I'm going to worry about its validity. Okay, so the first part, let's make it into a conditional statement. So they tell you what the hypothesis is. They tell you what the conclusion is. Okay, so the first conditional statement is going to be, if you are a guitar player, then you are a musician. Okay, so if, then Q. Okay, if P, then Q. Now for the converse, we're going to switch the hypothesis and the conclusion. Okay, sorry about that noise. Let me put my phone on silent before it continues. I had the phone right next to the microphone, guys, so it's gonna hear everything. Okay, phone on silent. Okay, so the converse Q, then hypothesis P. So if, now instead of saying if you are a guitar player, we're gonna have if you are a musician. Okay, if you are a musician, then you are a guitar player. Okay, and my microphone's a little sensitive, so you might just picked up my wife yelling at my little boy. Okay, now the inverse. It's really the negation of both of these statements right here, because look, if not P, then not Q. This is if P, then Q. And all it is just the same sentence, just like with a not in there. Okay, so if you are not a guitar player, then you are not a musician. We'll come back and determine true or false in just a bit. Now, the contrapositive is kind of like the negation of the converse, kind of like the inverse of the converse, because we're going to be negating this statement. So if you are not a musician, that's not how you spell musician. If you are not a musician, then you are not a guitar player. Okay. All right. So now what we're going to do is we're going to go back and we're going to see about the validity of these statements. Okay. So in the very first one, if you're a guitar player, then you are a musician. Well, that's true. All guitar players are musicians. So that's true. If you're a musician, then you're a guitar player. Well, we know that's false because, you could be a musician and not be a guitar player. You could play the piano or something. So that is false. Okay? If you are not a guitar player, then you are not a musician. That is false. And the last one, if you're not a musician, then you're not a guitar player. And we know that's true. If you're not a musician, you don't play anything. Okay, and that's question number 3. I'm going to put everything on the frame. Let me zoom it out a little bit. Remember, pause the video and go back and see it as many times as you guys need to. All right, question 4. Decide whether each statement about the diagram is true and explain your answers using definitions. Okay, so let's look at the very first one. AC is perpendicular to BD. According to the diagram, you see that little square right there? That means that that's a right angle and it's perpendicular. So in this case, AC is perpendicular to BD. So that right there is definitely true. Okay, it's because of that right angle symbol. All right, the next one. AEB and CEB are a linear pair. Okay, well, if this is a right angle, then so is this, and their sum is 180 degrees. So therefore, this is going to be a linear pair. Two angles that add up to 180 and are adjacent to each other, they're a linear pair. All right. EA and EB are opposite rays. We know that's false because in order for EA and EB to be opposite rays, A, E, and B have to be collinear points, and we know that's not true here. So this will be false. All right, let's take a look at the last one. Okay, it says rewrite the definition of perpendicular lines as a single biconditional statement. Okay, so I'm just going to cut right straight to it. If two lines intersect to form a right angle, then they are perpendicular lines. If I were to write the converse of that, it would sound something like this. If two lines are perpendicular, then they intersect to form a right angle. Okay, so in order to write a biconditional, all you really have to do is drop the if and the then and write an if and only if. Okay, so this is how it's going to read. Okay, two lines intersect to form a right angle if, write that down right, if and only if they are perpendicular lines. Okay. Now, if there's a word that you can't read because my handwriting is horrible, please let me know, okay? Because I tend to write really, really ugly most of the time, okay? All right, so if you guys have any questions, please make sure you have them for me when we do our live instruction, all right? And that is it for lesson 2.1. Have a great day.